Phosgene, the deadliest weapon in World War I. A tale of a vastly superior chemical warfare compound. Name?
My name's Charlie, sir. Charlie Winthrop.
Do you have an appointment with us today?
I didn't do that. I thought I could just walk in and get an appointment. Can I have one? Is it true you're a chemical weapons specialist?
Can you not read the name tag? Please get to the point.
I want to get certified.
You think you have what it takes to be a chemical weapons specialist? Please, they don't just give these degrees out.
They don't? How'd you get certified?
That's not important.
Sir, please, I'm a specialist in Phosgene. I can prove I have what it takes to be a chemical weapons specialist.
In order to prove that you have what it takes to be a chemical weapons specialist, I'm going to take you out in the field. I want you to tell me everything you know about Phosgene. Let's go. We made it. The field. Now tell me what you know about Phosgene.
But of course, sir, Phosgene's my bread and butter. Weighing in at a hefty 98.92 grams per mole and with a molecular formula of COCl2, it's clear to see why Phosgene's my favorite molecule. The glorious thing about Phosgene is its simplicity, with the central carbon atom double bonded to an oxygen and single bonded to two chlorines. It may seem simple on a surface level, but let me tell you, it sure packs a punch. Alright kid, you're clearly well read. I want you to tell me the history of Phosgene and why it was used above other compounds in World War I. Think you can manage that? World War I focused primarily on the use of chemical warfare. And prior to the use of Phosgene, this warfare was relatively ineffective and easily prevented. Phosgene was a revolutionary change to the warfare. Being a colorless gas made it more difficult to detect. It was more potent than any other chemical weapon used at that time, as well as it had the property of being more dense in air. This allowed for Phosgene to seep down into trenches and stay there, trapping enemies. Because it seeped into trenches, it made it more difficult to clear out and was more effective in targeting enemies on the other line. As you can see, Phosgene is a highly valuable compound. Not only was it extremely effective in World War I, but it continues to benefit us to this day. Well done, well done. I'm impressed with your work thus far, but for your final test, tell me some possible future applications of Phosgene. Sir, you didn't have to give me a softball for the last question. Phosgene is just as relevant nowadays as it was in World War I. Following World War I, Phosgene was seen as unethical and banned from chemical warfare. However, that didn't prevent us from using it today. Phosgene is still used in the field of manufacturing to help produce things such as plastics that we use daily. In addition to that, Phosgene is still used in the agricultural field today. We use it to make things such as pesticides to help farmers keep our crops nice and healthy. Stupendous job, rookie. I was doubtful when you walked into my office this morning, and I thought there was no way you had the chops to make it. But you've proven yourself knowledgeable enough to become a specialist in chemical warfare weapons. Sir, thank you for allowing me to express my passion for Phosgene and allowing me to convince others why it is the vastly superior molecule.
The historical context of Phosgene.
Thus, Phosgene gas. This was the next step in the progression. The French retaliated against chlorine gas with Phosgene. Now, Phosgene was a potent killing agent, deadlier than chlorine. One semi-drawback, though, was that some of the symptoms of exposure took 24 hours or more to manifest. That meant that the victims were initially still capable of putting up a fight, although this could also mean that apparently fit troops would be incapacitated by the effects of the gas on the following day. Colorless and having an odor likened to moldy hay, Phosgene was difficult to detect, making it a more effective weapon. It was sometimes used on its own, but was more often mixed with an equal volume of chlorine to help it spread across the battlefield. Although Phosgene was never as notorious in the public consciousness as our next gas, it killed far more people. About 85% of the 100,000 deaths caused by chemical weapons during the war.
The production process of phosgene.
You have carbon monoxide and carbon dioxide. A reaction in the presence of sunlight. Reaction in the presence of sunlight. Yes, now this is also the same heading. So when we are writing reactions in the presence of sunlight, observe carefully. Your carbon monoxide, I said it is poisonous or toxic in nature. So what does it do? Your carbon monoxide will combine with chlorine present in the atmosphere, which exists as free radicals Cl and Cl, free radicals. Yes, this occurs, or this reaction occurs in the presence of sunlight, and this, when combines with chlorine atom, it forms a compound called phosgene, that is COCl2. A very famous question. This is in grade 12 also they have phosgene. So what is this? Phosgene is also poisonous in nature. So what happens? If this concentration of phosgene is less than 2 ppm parts per million to 3 ppm, not a problem. Problem means you will just have eye irritation. But if this concentration increases more than that, if this is more than that, greater than 2 ppm or greater than 3 ppm, a condition called non-cardiogenic pulmonary edema. That means there is non-cardiogenic pulmonary edema, there is accumulation of fluid in the lungs. This causes this phosgene inhalation, it causes accumulation of fluid in the lungs, and that condition is called non-pulmonary. I have to write pulmonary edema. Edema is accumulation of fluid.
Looking at saved footage from World War I allows us to see many of the struggles phosgene caused on the battlefield. As you can see, there's an oncoming gas attack from enemies on the other line, and soldiers brace for impact. At this point, you can see soldiers rushing to grab their gas masks. Time is of the essence, and if they don't cover up their faces and prevent themselves from inhaling the gas, it can lead to even worse problems in the future. As the wind picks up and the onslaught of gas becomes more brutal, it is important for them to test to see what kind of gas they're dealing with. In this instance, they are dealing with phosgene gas, and knowing what type of gas it is can help them plan accordingly. The soldiers duck down into the trench to protect themselves from the fire so they can thoroughly analyze the gas. In this situation, the phosgene gas is filling up the trench rapidly. However, they must remain under cover or else they might get shot from enemy lines. Because of phosgene's lethality and effectiveness, numerous ad campaigns were opened to warn the public of its dangers. These campaigns helped inform citizens of how to tell if phosgene was present in the area. Unfortunately, if you smelled its characteristic hay-like smell, it was already too late and you had already had a lethal dosage. Phosgene gas can be an irritant and lead to terrible symptoms such as irritated eyes. Phosgene exposure can also lead to coughing and strained breathing. It can also lead to painful skin lesions or a burning sensation in your throat. However, high doses of phosgene can result in 46 hours after the initial phosgene exposure, another terrible symptom occurs. Fluid buildup occurs in the lungs, which slowly drowns out the sufferer. At this point, treatment becomes extremely difficult, and the likelihood of the sufferer dying becomes greatly increased. Phosgene is extremely dangerous and highly effective, and that is why it is a vastly superior chemical warfare compound.